Okay, so next we're going to look at the 45, 45, 90 triangle. And how do we get the ratios for this triangle? So first let's look at a square. And a square has 90-degree angles and all of the sides are equilateral. So if this portion is 1, then this is 1, and that's 1. I'm just using 1 as an example. You can pick any number. So now what I'm going to do is I'm going to bisect this square. And when I do that, I get the one that's below. Now notice how these two sides are still, the same length. So if this is 1, then this will also still be 1. Now, how do we determine what the hypotenuse is? Oh, actually, before we even get to that, the nice thing about squares is that their diagonals bisect the angle. So if this is 90 degrees, half of that is 45, 45. So now we've got ourselves a 45, 45, 90 triangle. So if your two legs are 1, how can we determine what our hypotenuse is? Well, again, because this is a right triangle, we can say that 1 squared plus 1 squared is equal to c squared. So 2 is equal to c squared. And again, normally when we incorporate a square root, you would assume the positive and the negative. However, because we're dealing with a distance or a side length, we're going to assume just the positive. So this is the square root of 2 is equal to c. So this side length here is the square root of 2. Now, if you'll look at this, you can also think of this as putting a 1 in front of it, the one that would match up with the other two side lengths. So if we wanted to come up with a ratio relationship or a side relationship, you can think of the following. X, and x times the square root of 2.